I will talk today about the Internet of Things and the impact on the database. And as you can see on my t-shirt, I'm working with MongoDB. And we have built a database that should help you to build new type of application. And which type of application you want to build is, long time ago, I was not even born when you use this kind of machines. So when you want to enter data in your database, you have to take a card, pinch it, and you can go as fast as one guy doing pinch, 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 putting the card in the computer. But today, we have a different way of entering data in the database. You can use your smartphone, you can use your wristband, sports stuff, computer, obviously, but also your cars, your electric grid will send data that you want to analyze. So when we talk about Internet of Things, it's many things indeed. It's everything. Everything that potentially that can capture data, then send them back over the internet somewhere will be used as a source of data that you will have to analyze. In fact, we are already doing many things with data. We are already in the Internet of Things stuff. Since 2007, 2006, we have more devices connected than humans. How many of us, I guess, you have a computer, you have a phone, and potentially you have another computer at work, and maybe another computer at home. So you see, in 2015, so next year, they will estimate that every human will have 4 devices that will be connected on the internet. So one of the challenges for us now as a developer, as a system administrator, is we have to deal with a lot more data than before. Every time you plug something, potentially it will send data to your application. So you need to find a way to deal with ingestions of this data. So I put other devices, and I put the smartwatch, I put the Google Glass, and even a tractor where you have a farm where people can use stuff to measure how many water do you need on a specific ground, and specific way of working with your field, your GPS data, so you will see some information about water you have to put on the ground, about the geolocalization where you want to put data, or when you want to put water compared to last year on this kind of stuff. So you need a database to deal with that. But you need a database that can really, really take a lot of data in the same time, because everything will send data every second. Every second you will have 1,000, million of operations that you can come inside your database just to insert the information. So if you look at some numbers, compared to what we have in 2010, we can estimate that the volume of data that we will have over the internet will be 50 times bigger. In 2020, coming from data that Cisco has looked at, we will have more than 5,000 gigabytes per users. It's crazy. It's crazy that you have to deal with so much data. What is interesting for us in IT, as a developer, as a system administrator, it allows us to build a new type of application. But talking about all this data, the first thing we have to do before processing them, we have to store them. You have to put them somewhere. It's easy to find and to send the data over the network, but where do you store? How do you analyze that? How do you use them inside your application? So this is one of the reasons MongoDB has been built, to be able to help you to capture this data, but also to analyze and process this data. If you look of why, or what was the vision, when in 2007, the founder of MongoDB has created the database, they have a specific vision in mind. 2 parts. One was about the development. So the build part. You want something that you deal with the complexity of your data. Many different types of data. Lot of data. So it has to be easy to deal with the complexity of the data, but also your application will be online all the time, so it must be flexible. You must be, as a developer, be able to change your schemas. You'll be able to add a new type of data easily. No need to stop your database to say, oh, I have to define a new schema, stop the database, restart the database. You cannot do that because your applications, your devices are sending data all the time. And also, we see more and more languages coming on the market. Probably when MongoDB was created, Node.js, so the Java server, the JavaScript server, the middleware where we develop in JavaScript web application on the server side, was not that popular. Today, it's very, very popular stuff in startups. We talk about Go language, the language from Google that is creating binary applications. So you need to be able to also to adapt not only to the data itself, but the web programmers are working, the web developers are working. And the most important, at least for me, it's one of the very important part, you need to ease the development. You need to make it fast. You want to be able to create new features very fast, to be able to deliver new service to your users. And especially, we have something special with mobile application. You don't know when your application will be visible by the user. You publish it on Google Play, or you publish it on Apple Store. After a few days or after a few weeks, it's available for your user. So you don't control exactly when the feature will be online. So this is one of the reasons you need something flexible, dealing with complexity of the data, and easy to develop. And the other part, it's about the deployment itself. You want to be able to run your database with the scalability that you need. Start small and grow your application, grow the size of your database easily. And he has to go from one small server on the cloud to hundreds of servers on the cloud. Two things are important here: horizontal scalability and the fact that you want to deploy on an infrastructure that is not that powerful. So you want to be able to work on commodity servers. Creating a database that deals with a very large volume of users, with a very large volume of data on commodity server was one of the main goals of MongoDB to run in production. So, because of this vision, the community behind MongoDB has been built very, very quickly, and it's huge today. We have more than 7 million downloads of the product. And one of the reasons you can meet many developers, it's because we have free online training. So don't hesitate to go to educationmongodb.com and learn about MongoDB. You can be trained on Java, on Python, on Node.js, how to develop with it. So how do we do that? So if you look back at this specific picture, we have many sensors. Stuff coming from GPS, stuff coming from your smartphone, stuff coming from Google Glass. None of them will send you the same message. So you have different format. And most of the time what you will have is, if you look at the left side, so the JSON document, you see that we have information about a vehicle, about the owner of a car, and you have the tracking information. Tracking information will contain timestamp, geo information, because in this case it could be GPS stuff, the current speed of the car. And you can imagine, so for example, for your electric consumptions, you will send timestamp, how many watts do you currently consuming in your house? What is the temperature of your house? And so on and so on. So many different messages that you will send. And you need to be sure that every time you add a new device to your application, or every time you have a new version of your device, the new schemas, the new data types can be consumed by your database. So one of the choice of implementation that MongoDB developer has done, it's to use JSON document. So it's a document-oriented database. That means you save a document, kind of your object, directly like this inside the database. And after that, you can query and you can do calculation and aggregation on different fields. For example, we have the timestamp. So you will be able to calculate how many cars has been passing in this specific location or specific part of the city from 1 to 2 p.m. What was the average consumption of my house during the night or during one day or during 1 month? So you need to store and you need to calculate, so do some aggregation on specific fields. So MongoDB has built a query language that allow you to quickly save, update, and aggregate data that are stored in this format. And what is interesting is at any time, you can add new fields, or you can have the same kind of documents, adding new fields or changing the schema depending on your business needs. So many Davis, many format. So one other point that is key, I'm talking about the big data part, meaning a lot of data that you have to save into the database. What means big data? Honestly, I have no clue. For my mother, when it doesn't stay on an Excel spreadsheet, it's big data. For Google, we don't know how many servers they have. But what is important for you is you need to be sure when you start on day one, on a month later, if you are lucky, you have 50 million users, and each user will have 1 gigabyte of data. You need to be able to store that. And one way of doing it is to distribute the data horizontally on many nodes. It's what we call horizontal scalability, the sharding or the partitioning of your database. It's what has been built inside MongoDB. So you can choose the way you want to distribute the data physically on different nodes. So when you start, for example, with 5 nodes, and you start to have more and more data, just add few Amazon instances or Windows Azure or Google Azure, Google Compute Engine nodes, and add new power, new storage to your database. So one of the key points here is to be able to do that easily. And the big difference between a relational database and MongoDB, we have this distribution of the data built in. It's very easy. You start small, you add new nodes, the server will distribute the data for you. Obviously, you have to decide how you want to do it. Do you want to do it on a specific date? Do you want to do it on a specific regions? Do you want to mix regions on dates? It's part of your design. It's part of the role of the job of the DBA, of the system manager. The same way you want to scale out, you also need to be sure your database is always on. When you publish a service on the internet, you cannot stop the service. If you stop the service, people will move to your competition. How many of you have downloaded an application on your phone? It's working for 5 minutes, it's crashing. You don't come back. You remove it from your device, you take another application. You don't want that in your application. You don't want that on your online service. So not only you need to scale out to be sure you have proper performance, but you also want to be sure that it's highly available. For that, we have replication built in inside MongoDB. So every time you will deploy a database, if you want to make it highly available, you just use what we call a replica set. So you have replicas, so you have primary nodes and secondary nodes that will automatically work together and duplicate and replicate the data on different nodes. Like that, if at any moment of time, for whatever reason, network failure, Amazon failure, sometimes remember 2 years ago when the Virginia data center of Amazon was not on the grid anymore, the network failed. If you have defined properly your cluster, one of the nodes or multiple nodes will be on another zone, so your database will always be available. So just having built-in replication, same, easy to do. Just install, configure, and you have a replicated cluster, a replicated database, and a distributed database. So we have specific use cases that has been built at the top of MongoDB and the Internet of Things. One good example is Bosch. Bosch is building many devices, from your laundry stuff in your house, from very small electronic device you have in your cars. It's many, many, many things. What is the value for them? not only they want any manufacturer to use their device, but they also want to add new services to the users. Some of the stuff they will do is to add more and more software in addition to their hardware. To capture data, send this somewhere. Maybe it will be on your personal website, maybe it will be on their own website, or maybe it will be on the manufacturer database. Just to know how many water my laundry is consuming every year. Can I improve that? Do I have, when I put 5 kilograms or 10 kilograms of stuff in my laundry, how effective it is? This is the type of stuff they want to build. They have built a full infrastructure that not only use hardware, but add software to allow you to build a new type of application. Same, sending many, many data to the applications. So the value for them, it's not in the hardware, it's on the services you can build at the top of it. Another example, it's Masternode. Masternode is helping companies, helping enterprise to deal with their fleet, cars, trucks, giving many services about where is this specific car or where is this specific truck. When do I have to put that on for service? When do I have to do the oil change? So it will capture many, many data for basic usage, just capturing data to have some information about kind of controlling the car is working properly, who is using at a specific moment of time, but also building a new type of services at the top of it. Once again, it's all about capturing the data and then dealing with that. We have other examples that you can find on our website using, for example, mobile phone application. So what they do, Telefonica, for example, will use and capture some data about their customer on their user base to capture which type of user is at a specific location, to know in the city where it's the best place to open a shop. You are a coffee maker, you are Starbucks, and you want to see where can I open a bar or a new coffee in the city. I know that my customer base is between 35 and 45-year-old, and most of the time they are coming from for lunch or after lunch. What is the best place in the city to find this type of audience? Manufacturer of any type of device, cars, will be able to build stuff. And what is interesting for you today is you can find many devices that are already sending data over the internet, that are already connected to the internet. And we see many new applications coming out of healthcare, how to manage, for example, blood pressure or sugar for diabetics people, and be sure that you want to alert them when something is going wrong. Sending that to the doctor, and the doctor will be able to analyze directly when the patient is coming to the office to understand what's going on. And for this, you need to store the data. You need to be able to process the data in an efficient way. So this is one of the reasons MongoDB is very helpful for you. So, do you have any questions? No? So, who has built application at the top of MongoDB or a NoSQL database today? Nobody yet? So it's very interesting to see that the adoption is going very fast, because what will happen is you need to be familiar with the document design. So how do you design your database? And you will see that you can quickly add new feature to this to build a new type of application. This is why we see, again, this kind of geo-lock applications, mobile application be built at the top of MongoDB, just to give the flexibility to the developer. Was shorter than I was expected. So, as I said here, we have a booth here, so if you want to learn more about MongoDB, show some demonstration, I can show you some demonstration, how we design document, how you build application, because it's really a new way of dealing with your data. Thank you.